In 1973, an insurance salesman in Virginia had a problem. Tom Rogers loved hunting wild turkeys, and the birds were vanishing. Across the American South, turkey populations had fallen to around 1.3 million, a sliver of what the land once supported. Rogers didn't have a biology degree, he didn't have institutional backing. What he had was $10,000 in personal savings and a cigar box stuffed with membership cards. He used them to charter the National Wild Turkey Federation, a hunting organization with one explicit purpose: put more turkeys in the woods so people could hunt them. Nobody involved was thinking about endangered species. Nobody was drafting a plan to save an ancient forest. The mission was game birds, full stop. Breeding them, protecting them, and manufacturing the kind of habitat where their chicks could survive. But over the next 5 decades, that hunting club would spend $500 million reshaping the forests of the American South. And in October 2024, the United States Fish and Wildlife Service officially downgraded the threat classification of a small black and white woodpecker that no turkey hunter had ever aimed at. A bird that had been sliding toward extinction for 50 years, while the federal government tried everything it could think of to save it. How does a hunting organization spend $500 million chasing one species and accidentally rescue a completely different one? To understand why turkey hunters started tearing forests apart, you need to understand what a baby turkey requires to survive its first month alive. An adult wild turkey is a tough, adaptable bird. It roosts in tall trees, eats acorns and hard seeds through winter, and handles a wide range of forest types without complaint. But a turkey chick, a poult, is an entirely different engineering problem. Poults hatch directly on the ground. They can't fly for weeks. And during those first critical weeks, they need one thing above all else: insects. Enormous quantities of insects. A poult's diet in its opening month is almost entirely protein from beetles, grasshoppers, spiders, and caterpillars. Without that protein surge, the chick doesn't grow feathers fast enough, doesn't develop fast enough, and doesn't survive. The catch is that poults can't forage in just any patch of woodland. They need a very specific geometry on the forest floor. The ground has to be open enough at soil level for a bird the size of a tennis ball to walk through and pick off bugs without getting tangled. But the vegetation has to be tall enough overhead, knee-high roughly, to hide the chick from hawks. And the entire area has to be flooded with sunlight, because insects concentrate where the sun hits the ground, not in deep shade. By the 1970s, the forests of the American South had almost none of this. Decades of aggressive fire suppression had fundamentally transformed the region's woodlands. In the absence of the low, fast-moving surface fires that had swept through these forests every few years for thousands of years, fast-growing hardwoods, oaks, sweet gums, dense scrub, had invaded from below and formed an impenetrable wall of vegetation between the forest floor and the canopy. The floor itself was buried under a thick, wet mat of decaying hardwood leaves that no sunlight could penetrate. No native grasses grew, no wildflowers bloomed, no insects concentrated in the open because there was no open ground left. For wild turkey poults, these forests were dead zones. The chicks hatched into darkness and starved. This was the problem Rogers and the NWTF set out to solve. Not the forest as a system, not the ecology, the geometry. They needed to tear down the wall of vegetation between the floor and the canopy, get light onto the soil, and grow the kind of ground cover that would feed billions of insects that would feed millions of turkey poults. The mission was practical and narrow: manufacture ideal brood-rearing habitat at the largest possible scale. What the hunters didn't realize, what nobody understood at the time, was that the geometry they needed for their game bird was the exact structure an ancient ecosystem had evolved around, and that a federally endangered species living in the canopy directly above them was dying for the want of it. The NWTF started with the cigar box and grew into a grassroots fundraising machine. Local chapters, banquet dinners, donated shotguns, every dollar multiplied by federal excise taxes on ammunition that channeled money back into wildlife management. Within 2 decades, the organization was reshaping landscapes at a continental scale. The money went into 2 interlocking physical interventions deployed across the Southeast. The first was mechanical subtraction. In forests where decades without fire had allowed the hardwood mid-story to grow thick and tall, heavy equipment went in. Crews with chainsaws and masticating machines physically cut down the invading oaks and sweet gums, peeling back the dense wall of vegetation layer by layer. Where mechanical removal wasn't practical, targeted herbicide was applied to stumps to prevent resprouting. The work was ugly. Treated sites looked ruined in the first months, slashed piles, dead standing timber, scorched ground. The forests appeared worse, not better. Landowners walking their property in that first year could be forgiven for thinking the whole operation was a mistake. The second intervention was fire. Once the dense mid-story was knocked back far enough to safely carry a low flame, land managers walked through with drip torches, setting deliberate surface fires on a 1 to 3 year rotation. The fire did several things at once. It consumed the suffocating leaf litter, exposing bare mineral soil. It killed hardwood saplings trying to regrow. And it cracked open the seed coats of native grasses and wildflowers that had been locked in the soil for decades, sometimes generations, waiting for exactly this chemical signal. Within a single growing season after the first burn, treated sites erupted. Wiregrass, legumes, and flowering plants surged to knee height. Insect populations followed almost immediately. Beetles, grasshoppers, spiders flooding into the sunlit ground cover in enormous numbers. The geometry was finally right. Open at the ankles, dense at the knees, drenched in light. Turkey poults could walk, feed, and hide. Alongside the burning and thinning, the NWTF ran a parallel campaign to stock the winter food supply. Through coordinated programs, Operation Oak across the southeast, Operation Heartland in the Midwest, Operation Appleseed in the Northeast, the organization sourced, shipped, and planted over 2.6 million nut-producing and fruit-bearing seedlings across degraded land nationwide. Oaks, crabapples, hawthorns planted in stream corridors and low areas where they wouldn't interfere with the open pine stands being managed for fire. From $10,000 and a cigar box, the operation expanded into a $500 million continental program, touching over 22 million acres of habitat. And the primary objective was met comprehensively. Wild turkey populations climbed from 1.3 million birds in the early 1970s to more than 6 million by the 2020s, one of the most successful game species recoveries in North American history. But buried inside that success, field biologists started noticing something they hadn't been looking for. In the newly opened pine stands across the southeast, small black and white birds were moving into the canopy, excavating holes in living pines, and setting up territories in forests that had been managed purely and exclusively for a ground-nesting game bird. Nobody had funded this. Nobody had planned for it. The birds were showing up on their own, breeding and expanding. The hunting operation had built something it hadn't intended to build. The bird arriving uninvited was the red-cockaded woodpecker, a species that had been listed as endangered since 1970 and had spent the following decades getting rarer, despite every protection the law could offer. By the late 1970s, the population had bottomed out at roughly 1,500 active family groups scattered across the southeast, clinging to the last scraps of old-growth pine. For decades, the standard approach to saving this bird followed a simple logic. Draw a protective boundary around every known colony, ban all logging and disturbance inside the line, and leave the forest alone. The assumption was that the bird needed protection from human activity. The assumption was exactly wrong. The red-cockaded woodpecker is the only woodpecker in North America that nests exclusively in living pine trees. A breeding pair spends years chiseling a single cavity into wood that's been softened by a specific fungus attacking the heartwood of old pines. Once the cavity is finished, the birds peck wounds around the entrance to keep resin flowing down the trunk, a sticky barrier that climbing snakes cannot cross. But the defense has one critical vulnerability. It only works if the pine stands alone, with clear air between it and anything a snake could climb. The moment a neighboring hardwood grows tall enough to touch the cavity tree, a snake can simply climb the oak, cross over on a branch, and bypass the resin entirely. A closed canopy also blocks the flight paths the woodpecker needs to reach its nest, and a shaded forest floor produces almost no insects, starving the birds of their primary food. So when the federal government drew its protective circles and banned all disturbance, the hardwood mid-story kept growing, entirely unchecked. Within years, the protected zones became the worst possible habitat. Snakes bypassed the resin. Flight paths closed. Insects vanished. The woodpeckers abandoned the protected sites or died in them, and the perverse incentives rippled outward. Private landowners across the South, 73% of remaining longleaf pine habitat sits on private land, quickly learned that if woodpeckers colonized their property, the regulatory consequences could shut down timber operations entirely. The rational economic response was to cut pines before they ever grew old enough to attract the bird. Landowners shortened their harvest rotations preemptively, ensuring their trees never reached the age a woodpecker might want. The law designed to save the bird was accelerating the destruction of its habitat. The mechanism connecting turkey hunting to woodpecker survival was simple. The open, sunlit forest floor that turkey poults needed for foraging was maintained by the same ancient process that the longleaf pine savanna had relied on for millions of years: frequent, low-intensity surface fire. The forests of the southeast hadn't always been dark, closed canopy tangles. For most of their evolutionary history, they were open, sun-drenched savannas, towering pines spaced widely apart over a carpet of waist-high grass, swept by fire every 1 to 3 years. Fire kept the hardwoods down, fire kept the floor open, fire kept the grass growing, the insects thriving, the canopy clear. Every species in the system, the turkeys, the woodpeckers, the grasses, the pines themselves, had evolved to depend on that fire. When humans stopped it, every piece failed simultaneously. When the turkey hunters brought fire back, every piece came back together. The data, once biologists started looking, was unambiguous. By the late 1990s and early 2000s, the woodpecker clusters showing population growth were located almost exclusively on land that had been thinned and burned for wild turkey management. The geometry that fed turkey poults, open at the ankles, dense at the knees, flooded with light, was the same geometry that protected woodpecker cavities, cleared flight paths, and grew the insects both species needed. And the cascade didn't stop at woodpeckers. As the open savanna structure reestablished across the southeast, the gopher tortoise returned, an ancient reptile that digs deep burrows in the sandy, sun-warmed soil of open pine flats. A single tortoise excavates a tunnel that can stretch 40 feet long and 10 feet deep. And those tunnels are not private property. Over 350 other species shelter in gopher tortoise burrows: indigo snakes, burrowing owls, mice, frogs, insects, using the tunnels as refuge from fire, heat, cold, and predators. When the canopy had closed and the soil went dark and cool, the tortoises disappeared. And when the tortoises disappeared, 350 tenants lost their homes. When the turkey hunters opened the canopy back up, the tortoises returned. And so did everything that lived in their tunnels. The project hadn't just put more turkeys in the woods, it had accidentally restarted a biome. The numbers tell the rest of the story, and they come from multiple decades and multiple domains. The red-cockaded woodpecker, which bottomed out at roughly 1,500 active clusters in the late 1970s, climbed to approximately 7,800 clusters spread across 11 states by the early 2020s. On October 25, 2024, the U.S. Fish and Wildlife Service officially reclassified the species from endangered to threatened, the first improvement in its legal status in over half a century. The federal ruling specifically credited decades of collaborative forest management, naming mechanical thinning and prescribed burning on public and private lands as the primary mechanical driver of the recovery. Chainsaws and drip torches, funded by hunters buying banquet tickets, accomplished what 50 years of regulatory protection had failed to deliver. The longleaf pine ecosystem itself, which had collapsed from 90 million acres to fewer than 3 million, a 97% loss, has begun climbing back. Through targeted replanting by the NWTF, the U.S. Forest Service, and private landowners enrolled in federal programs, the footprint has grown to nearly 5 million acres and is still expanding. In southwest Georgia, watershed modeling has uncovered yet another benefit that nobody designed. Restoring the open savanna structure reduces the amount of water that dense trees pull from the ground, increasing stream flow by up to 3.8 million gallons per day in a single river basin. Forest management built for a game bird has become a water supply tool. The system is not bulletproof. In 2018, Hurricane Michael tore through the Florida Panhandle and flattened tracts of mature longleaf pine that had taken decades to restore, wiping out cavity trees and entire woodpecker colonies in a single night. Biologists scrambled to install artificial nesting inserts in the surviving pines, racing to keep the breeding groups intact. The event exposed the fundamental fragility of managing small, isolated populations in hurricane country and the permanent cost of keeping the engine running, because this system does not heal and then hold. The longleaf pine savanna is a machine that requires a human hand on the ignition permanently. If the burns stop for a single decade, the hardwoods return, the canopy closes, and the entire cascade collapses backward. Woodpeckers, tortoises, 350 tunnel-dwelling species, all of it. The federal government recognized this and built a new regulatory tool around the accident. Safe harbor agreements flipped the old incentive. Landowners who burn and thin their property face no additional restrictions if woodpeckers move in. The endangered species presence becomes a benefit, not a liability. The fuel for the entire engine, the money, the labor, the political will to keep burning millions of acres of forest on a permanent rotation still comes overwhelmingly from the same source it came from in 1973: hunters, writing checks, buying tickets, funding the burns that keep the floor open, the insects thick, and the canopy clear, because they want to hear a gobbler at dawn. $10,000 in a cigar box. That was the seed capital for one of the largest accidental ecosystem restorations in North American history. Sometimes the most effective environmental engineering is the kind nobody set out to do. The longleaf pine savanna wasn't saved by a federal recovery plan or a preservation mandate. It was saved by people who wanted to hunt turkeys and were willing to pay to reshape the forest to do it. The woodpecker was a side effect. The tortoise was a side effect. The ancient forest was a side effect. The only thing anyone was aiming at was the bird on the ground, and sometimes that is exactly enough. If you want to see more stories about how landscapes break and how they get fixed, subscribe.